I am Satvik Sawhney. This is SlotKeeper Fleet, my submission for the OpenEnv Hackathon Round 2. It's a multi-agent warehouse environment where LLM coordinates three robots, and the problem it solves is older than warehouses themselves. Let me show you. SlotKeeper Fleet is a multi-agent warehouse RL environment, but the actual problem it possesses is the cache eviction problem projected onto physical space. Phil Carton once famously said that there are only two hard problems in computer science: cache invalidation and naming things. We are adding a third one: cache eviction when eviction isn't free. When a CPU cache fills up, classical policies like LRU, LFU are kick out the least recently used item. They all share one assumption: eviction is free. Moving a cache line causes zero clock cycles. That assumption is the foundation of every textbook cache policy. Now project that onto Amazon, Blinkit, or Zepto black stores or warehouses. The dispatch lane is a CPU. The hot zone near dispatch is L1 workers, which means LRU is provably wrong here. The eviction is not free. Moving an item takes a robot, takes minutes, block workers. The optimal policy has to weigh expected future demands against the physical cost of moving each item. That's what we are posing as a benchmark. The environment is an 8 by 8 warehouse with 20 SKUs and 3 robots, two picker and one mover, coordinated by an LLM manager that assigns macro tasks every step. Four task variants stress different angles like static demand, shifting demand, constraint 6 slot hot zone, and search spikes. The behavior we want to the agent to learn and that emerges in the strong models is pre-fetching, pre-positioning high demand items at right time in the hot zone before they are even ordered. This is an interactive visualizer. Every replay here is a real recorded episode you can step through. We have 14 trajectories from 5 different managers: heuristic, classical LRU, and 3 frontier LLMs: Gemma 4331B, GLM 5.1, and MiniMax M2.7. You can scrub through any episode and watch the worker's actions, the order queue, and the reward breakdown level. Notice the mover prefetching in the hot zone. That's the emergent behavior the prompt alone produces. So after this, we fine-tuned and evaluated 5 frontier models on all 4 task variants. The heuristic floor, because only node organization sits at 0.499. Classical LRU climbs to 0.748. Then the LLMs jump above 0.80. With Minimax M2.7 at 0.802, GLM 5.1 at 0.856, Kimi K2.5 at 0.871, and 3 independent frontier models above LRU is signal, not noise. This is the genuine teaching something. We also trained a small deployable student, Qwen 2.5 at 1.5 billion parameters with LoRa through the full 4 stage pipeline: SFT, GRPO, DPO, and then finally Best-of-N. SFT pulled eval loss of 0.05225. GRPO ran end-to-end on Kaggle 2x 4 and gave us data points at 0.017, a useful negative we explain in the charts page. DPO and best of N round are out of the pipeline setup. The full curve summary JSONs and the trained adapter are all on the Hugging Face basis. Code environment reward pipeline and all 14 trajectories and the trained adapter are open on the Hugging Face basis right now. 5 frontier models, 4 task variants, one trained model, one new way to think about cache replacement. Thank you for watching.